For today's chapter exam, we were asked to use this website in order to determine which problem we do. So I inputted my birthday for this website, and it comes out to 1 plus 2 equals 3. And for the day, the month is 2 for February, and then the year, when you add it up, comes out to 4. So 3 plus 2 plus 4 equals 9. So today's problem we're going to solve is number 9 on the homework. So for part A of number 9, it states, some airliners use wires of aluminum resistivity 2.75 times 10 to the power of 8 rather than copper to reduce weight. The potential difference between the ends of the aluminum wire, 33 meters long, is 1.45 volts. When the wire carries current 1.2 amps, find the electric field magnitude inside the wire. So in order to solve for the electric field magnitude for part A, we need to use the equation E equals V divided by D. And both these values are provided to us in the problem. So for V, we have 1.45 volts, and then for the distance, we have 33 meters. And calculating this together, we get 4.39 times 10 to the power of negative 2 volts divided by meters. Volts divided by meters for part A. For part B, we have to, instead of solving for the electric field magnitude, we have to solve for the resistance instead. So the equation we would use instead of E equals V divided by D is R equals V divided by I. So both these values again are provided. So the two values that we're going to use are, we're going to use 1.45 again, but instead of 33 meters, we're going to use 1.2 amps for I. So 1.2, and when you calculate this, you get 1.21. So for part C, it wants us to find the cross-sectional area of the wire. So for part C, the equation that we would use would be R equals PL divided by A. And since we have all these values, we can fill in the equation. So it would be 1.21 equals 2.75 times 10 to the power of negative 8 times 33, and then we put this in parentheses, divided by A. So after calculating all of this, it will come out to A equals 7.51 times 10 to the power of negative 7 meters squared. So moving on to part D, the question states, when a current of 0.218 A is present in a wire 21 meters in length with a cross-sectional area of 8.19 times 10 to the power of 7 meters squared, the electric field inside of the wire is 6.5 times 10 to the power of negative 3 volts per meter. What is the resistance of the wire? So we're gonna clear this out real quick. In order to find the resistance of the wire, we first have to calculate for part D, E equals V divided by D. So first we would have to find the voltage. So instead we're going to rearrange it to V equals 6.5 times 10 to the power of negative 3, and then we're going to multiply this by 21 to get 0.13 0.365, and this will help us find the next section, which is the resistance. So the resistance, we'll plug in this value right here, 0.1365, and divide this by 0.218 in order to get 0.626 ohms. For part E, it wants us to find the resistivity of the material, of the wire. So we would use the same, equation as part C, except we were gonna rearrange it a bit. So we will take R equals PL divided by A, and since we want to find the resistivity, it'll be P equals AR divided by L. So plugging in our values, we have P equals 8.19 times 10 to the power of -7 times 0.626, and we'll divide all of this by 21, and our answer will come out to 2.44 times 10 to the power of -8 ohms meter. Part F states, two wires of circular cross-section are made of the same material. Wire 1 has radius R and length L. Wire 2 has radius 2R and length 2L. The potential difference between the ends of the wire is the same for both wires. Find the ratio of the resistance of wire 2 to the resistance of wire 1. So in order to do this, we are going to clear this real quick. We're going to use, for part F, R equals PL over A. And also we are going to use, we need to find R wire 2 and R wire 1. So R1 over R2 will equal PL, L over A, 1 over PL over A, 2. So when we fill in the values for A, it'll get PL over pi R squared, and then over P times 2L over pi 2R squared. And so R1 over R2 will equal 2. So, but if we do the reciprocal, R2 over R1 will equal 1 over 2 for part F. And then for part G, it wants us to find the ratio of the current wire 2 to the current wire 1. So it'll be, I wire 2 over I wire 1. So instead of using R, we're going to do I2 over I1 equals delta V over R2 over delta V over R1. And when we fill these in, it's actually just the same as, because it equals to R1 over R2. So we just use the same values up here. So it equals, since they're both equal, I2 over I1, the answer is 2. So for part H, it says find the ratio of the current density of wire 2 to the current density of wire 1. So we're going to be using J wire 2 over J wire 1. So let me clear this out real quick. So for part H, we're going to be doing J2 over J1. And this will equal to I2 over I1 times R2 over R1 squared. So when we do this, fill in the values, it'll be 2 times 1 over 2 squared, which equals, 2 times, 1 over 4? And when we add all these up, it'll equal 1 over 2 for part H. Part I asks for find the ratio of the electric field magnitude of wire 2 to the electric field magnitude of wire 1. So we're going to be using E wire 2 over E wire 1. So for part I, we're going to take E equals delta V over L. And so we're going to do E2 over E1. And this will also equal just to L1 over L2, which in turn is L over 2L, which basically just equals 1 over 2 for our answer. For part J, the question asks us, the current in a certain wire at 20 degrees Celsius is 2.4 amps when the potential difference between the ends of the wire is 1.5 volts. The wire is heated to 8 degrees Celsius and the potential difference remains the same. The current decreases to 2 amps. What is the resistance of the wire at 20 degrees Celsius? So for part J, we are going to do R, that's a weird R. R equals V divided by I. And since both these are provided, we'll have 1.5. And for 20 degrees, it is 2.4. So when we calculate this, we get 0.625. And for part K, it asks us the same thing, but if it was at 80 degrees. So for at 80 degrees, instead of 2.4, we're just going to use 2.0. And we get 0.75 for part K. Part L asks us, what is the temperature coefficient of resistivity of the material, or for the material of which this wire is made of? So we're going to clear my board real quick. So for part L, we are going to use the equation R2 equals R1 plus R1 times alpha times T2 minus T1. So we're going to switch R1 to the other side. So R2 minus R1 equals R1 alpha times T2 minus T1. And we want to get alpha to this side, so we're going to move alpha equals, let me redraw that. Alpha equals R2 minus R1 divided by R1 times T2 minus T1. And if we fill in the values for this, we will get alpha equals 0.75 minus 0.625 divided by 0.625 times 80 minus 20. And when we calculate all of this up, we will get 3.33 times 10 to the power negative 3 Celsius negative 1 to the power negative 1. And that is problem 9 of chapter 25.